Hey, what's up? I'm Liz, the Splitsia DIY, and today I'm going to talk about a couple different things. We're going to talk about MicroPython, and we're going to talk about the TinyPICO board. So first off, let's start off with the TinyPICO board. That's this board right here, this very tiny board. Let's hold up some things for comparison. Here's a feather shield. Let's see, feather eats Pico. And then we have a trinket. Trinket basically fits on top. Probably the thing that's closest to it would be an Itsy Bitsy, which is also about the same size as a tiny FPGA. It's kind of its own form factor. It's existing in its own little world. So the TinyPICO, the reason why I'm talking about it, is it's made by a friend of mine, Seon, down in Australia. He has a channel, Unexpected Maker, and he's doing a CrowdSupply campaign for his board right now. So this is the board site, tinypico.com, and basically it's a ESP32 development board. Pretty impressive engineering, how he got everything on here. So what's cool about this is it can run Arduino or MicroPython. There's Seon. There he is. It's available right now on CrowdSupply. Seon did send me this to take a look at. It's just always impressive when someone kind of makes their own board and everything. He's working on this with Matt Trentini, who is a MicroPython developer. So what I wanted to talk about today, one thing I did do to prep playing around with this was to set up a MicroPython kind of development environment on my computer. So Seon has a really great playlist on how to get started with MicroPython, but he uses Mac, which is great, don't get me wrong. I don't want to start any operating system wars, but I personally rock Windows. And I was curious if you could just do it natively on Windows. And I found out a way to do it so that you're on Windows, but you're technically not totally using Windows. And that is with Windows Subsystem for Linux. What? So you may have heard about this like a while ago. Basically, Windows Subsystem for Linux, if we read here in the Microsoft documentation, it's on Windows 10, enables you to run native Linux command line tools directly on Windows alongside your traditional Windows desktop and modern store apps. Yes. How many times have you been on Windows and thought to yourself, oh, if I could just do some quick bash, this would be so much easier, but I'm having to do something stupid instead. So, yeah, basically you're running a Linux terminal in your preferred distro on top of Windows. So you can access all your Windows file directories and everything like that through Linux. And you can also run things like you would on Linux. So that makes it really awesome for things with like GitHub repos and development and talking with boards and things like that. So I tried it out specifically for this. I'd been meaning to, and I'm glad I finally got to. But it took me a bit, so that's why I want to make this video to document it, how you can get a MicroPython environment set up on your Windows machine using WSL, Windows Subsystem for Linux. Doesn't have to be for a TinyPICO, it can be for anything you want, so I just wanted to kind of go over that. So step one, you need to get the Subsystem for Linux installed. The way you do that is, I'm sorry to say, you have to go to the dreaded Microsoft Store. I know. It's okay, we'll get through it. And you can see they have a few distros available. I'm going to tell you right now though, I started out with Debian, but I had better luck with Ubuntu. And Ubuntu was the first one they released, so I have a feeling there's been just a little bit more development to get it to run smoothly. So what you do is you click on your thing, and you get it. That's all you have to do. So after you install the Windows Subsystem, one thing you do have to do is you have to go into Windows Features, and you have to check off Windows Subsystem for Linux to enable it. You'll press OK, and then you'll probably have to reboot. But then after you reboot, you can open up a terminal in Ubuntu, and you'll be good to go. So then after that, you have to install your dependencies. So I'm going to go ahead and open up the Ubuntu terminal and see Liz as Reptar. If you're kind of new to the channel, you should know my computer is named Reptar. So I actually found this great step-by-step guide online, actually meant for the Odroid, getting MicroPython to run on Odroid. So they have like everything laid out there. I'm going to link this down in the description because it's a lot easier to reference, I think, in text your terminal entries rather than me talking them to you. Me talking them to you? Me talk pretty one day. So looking at here, basically you want to do an update, and then you want to install Python and Python pip. Now you may already have Python installed on your system. I like to just still try to run the install anyway. Worst case scenario is it's going to tell you it's already installed, so better safe than sorry. I'm going to just kind of demonstrate, and it's going to tell me it's already installed. But see, it's already installed, but as you can see, the terminal acts just like if you were on a native Linux install, so not too shabby. So after you have those installed, you can go ahead and install ESPTool. What's ESPTool? Well, it's basically the way to communicate with your ESP-based board, whether it be ESP8266 or an ESP32. And so by installing this and running it, you'll be able to versions of MicroPython on here. You'll also be able to work with the Flash and everything like that. So you need to install ESPTool before you do anything else. After you have ESPTool installed, you're going to need the firmware for MicroPython. And you can grab that from the MicroPython site, micropython.org. And you go to downloads, and you'll go to the board that you need. We're using an ESP32, but there's also other chips on here as well. So the firmware that I'm using, because it's a TinyPICO and it has SPI RAM on there, I'm actually using the latest binary. So what you do is you just click on that and you download it. Once you download it, you want to move it to a folder that you're going to have access to through the Ubuntu terminal. So if you just throw it in like documents or on your desktop, I have a special folder made for MicroPython in my documents that I can change directories to with Ubuntu to access. Now, after you have that downloaded, we can actually go ahead and flash the firmware onto the board. But first, you're going to need to be able to locate your board on a serial level. And since we're on Windows, ports are labeled with the COM numbering system. So mine comes up as COM43. Now, when you're in Linux, you don't use the COM naming system. You use /dev/tty, and then there's a number afterwards. Now, on here and in a lot of different references, I saw that the ESP32 is supposed to come up as TTY USB 0. That did not happen to me at all on Windows. It stayed as the COM43. And how that translated in the terminal, in fact, we can check it out with here with ls/dev/tty star. These are all my serial ports that are available. So the way that this is showing up, since it's COM43, is actually /dev/tty s43, and that's how I'm able to kind of talk to it. Now there's one more thing that we have to keep in mind before we get fully started, and that's serial support on the Windows Subsystem for Linux. This is still kind of a new thing, and serial support is still kind of a little sketchy. There is a way around it, though. You're basically going to change the mode of your serial device. And I've found that I have to do this every time I open up a new terminal window. And the way that you do it is you do change mode 666, and then you put in the name of your serial port. So let's start with that. So we're just going to copy that. And then if you want to copy and paste anything in terminal, just a right click. There we go. Now we're just going to change my port to S43 because that's my port. Your port will be different. You need to reference the device manager, look under the COM ports, and then you'll be able to translate that. So let's hit enter. This is change mode if you ever used it. There's no readout from it, so don't panic. Now, though, that we've basically accessed our serial port, we're ready to use the ESPTool to clear out the memory and load in the MicroPython firmware. So the commands for that are on the MicroPython site. And first we're going to copy this one, which is to erase the flash. Every time you update the firmware, you're going to want to erase the flash. So I'm just going to paste that in there. And again, I'm going to change my port number. And then we're going to hit enter. And we wait. We're all set. So it's been reset. Now, though, we're going to change directories in Ubuntu to the documents folder that I have set up that has the firmware binary that we're going to be loading in. So the way that you do that in Windows, it's similar to if you've ever used PowerShell. You have that /mnt/c/users, yada yada. That's how you can get into the Windows file system. Otherwise, you're in this kind of hidden folder that the Ubuntu distro is running in, and it's under like app data, users, and like the whole thing. So we're just going to do that. You can see now it's showing us, so we're in that file system. So now we can load in that binary, and we're going to do that with the load in line here. Paste it. So a couple changes we need to make. First, we got to change our serial port to S43. We're going to change the baud rate. I had better luck with 115200, which is the default baud rate, so it's not changing that. We keep the flash settings the same, and then we also have to change the name of the bin numbers. There we go. So if it works, you'll get this readout, and it will tell you that it's connected, it's configuring flash, and then it's writing. So it's going to be writing for a while. All right, so it only took about a minute and change, and we now have MicroPython loaded onto our board. So now we're ready to play around. We want to code in some Python. Come on. So there is a way to do that right in Ubuntu here, and the way that you do that is with OurShell. OurShell is another community tool that basically lets you control MicroPython with some fun command line things, and also with the Repple. Repple is basically using this kind of serial interface so that you can type to it and talk to it in real time. If you've ever seen any of Tony D's early Circuit Python tutorials with Adafruit, he was using the Repple. Basically, you're just opening up a serial communication between the board and the terminal so that you can chat with it. You install OurShell using sudo -h pip3 install OurShell. I've already done that, but just so you know. And then Seon has some example code for the TinyPICO, so I'm also going to change directories into that file folder system. And so now we're going to open up OurShell, and this will again vary with your board. But I've found the best way to do it for the TinyPICO is OurShell-P for port, throw in your serial port number, and then -B for baud rate, which the default is 115200. And then otherwise, OurShell is able to kind of detect what else the board is rocking. So if we enter in that, you'll get all this readout if it's working. Otherwise, you'll get some errors and things. Another possible thing that can throw an error is if you need to change mode to 666. That can throw an error that maybe you aren't aware of and can cause some frustrations. Other errors I've seen are if the board is kind of stuck in a boot loop, which then you can kind of reset using a jumper wire by grounding the reset pin, and then unplugging the USB, waiting a couple seconds, plugging it back in. That can sometimes jumpstart it. But just some things to keep in mind if you run into any issues. And these are all things I experienced, so I'm trying to help you out. So once you enter in that OurShell command, now in the terminal, you're actually in OurShell. You're not in just generic Ubuntu land. You're actually inside a program. So the first thing we're going to want to do is copy some programs over to the TinyPICO so that we'll be able to run them in Linux. So let's do ls, so list out the programs on there. So then we can copy some things over. We're not going to copy everything, just a couple things. First, we're going to want to copy the dependencies. So you can do that with cp tinypico.py. And then this is important. OurShell sees all boards as PyBoard, which is the official MicroPython sponsored dev boards. So the way that you send files over to whatever board you have in there is /pyboard/. That's just kind of a generic mask that all boards are wearing when they are connected to OurShell. So if we do that, there'll be a slight pause, and that shows up. And we're going to also need the .star library. So you can copy a whole folder over, but I've had more stability when in OurShell to copy things kind of one by one. So, and then the actual file we're going to be running is the .star simple test. So now what you can do is do ls/pyboard, and it'll show you the files that are actually on your MicroPython board. You can see everything we've copied over is hanging out there, having a good time. So now we can go into the REPL, and you do that by just typing REPL. And so for a little test, you can do print. I know everyone does hello world, but you know, maybe I don't want to type that much. And the way that you can run files that are on there is using import. So you do import, and then we're going to run the .star simple test, which I've edited a bit so that it flashes red, blue, green. And you don't need the .py extension, so you just hit that. And we're changing colors, maybe? Yeah. So I had some issues with the .star running properly. So as you can see, like how it's syncing up with the terminal, like with the text readout I have going, it's not syncing up with the LED, but we are changing the LED's color. My script is probably not as streamlined as I would like it to be, but it's working, and we sent a thing to the board. So proof of concept, it's there. As I said, I'm just getting started with this. So the way that you stop your script from running, and I recommend you do that, otherwise you might get into a loop, is to do Control-C. So same thing if you were on a Pi or a Tinker Board or any other single computer and running regular Python from the terminal, Control-C ends your program. And then you can also do a soft reboot with Control-D, whereas if you've ever used Moo with CircuitPython, that's also how you do a soft reboot. And then you exit out of the REPL with Control-X. And by doing Control-X, that brings you back into OurShell by default, and you can go back into the REPL really easily and kind of back and forth if you want. So you might be wondering how you would do like actual like coding for a project for this. What I've been doing is having OurShell open and then using idle to edit my Python files. And so what I'll do is I will basically like just edit the file. And this is in my directory that I'm in right now, the TinyPICO-helper. And so I just changed the little thing. And so what I'll do is I'll save it, and then I will just copy it back over to the board. And I can just use the up arrow to go to the command that I've already typed out, so I don't have to type everything all over again. Do that, and it overwrites the script that has the same name, so you don't have to worry about it throwing an error or anything like that. And then I can go back into the REPL and then import .star simple test, and it runs. So that's just a little bit on how to kind of get started with MicroPython in the Windows Subsystem for Linux. I think this has a lot of potential if you're a Windows person and you just want to have a little bit of access to Linux. Obviously, you could also do a full Linux install if you wanted the full environment, the full experience. But I think this is a pretty nice feature if you just want to be at your desk and like not have to move anything around or worry about anything like that. So that's going to do it for this video. I hope it was helpful for you. I hope it maybe helped you have a different way to approach MicroPython. Check out the TinyPICO now on CrowdSupply. We've got a little under a month left. Seon's working hard down under to get all those parts placed on the board. So if you like this video, toss me a thumbs up, leave any questions or comments down below. Down in the description, I'll have all the links I referenced in here so that you can take a look at it yourself if you try to get this set up. Thank you for watching. Consider subscribing for more content like this. And until next time, this has been Blitz City DIY.